As of about 2008, there were 5.6 billion gallons of gasoline wasted while people were just idling in traffic. There was, on average, 46 hours per year per person in the United States spent idling in traffic. That's almost 2 days of your time every year spent in traffic congestion. And that amounts to $63 billion annually due to congestion. And I just want to point out in this one, this poor guy right here is trying to direct traffic. A single person in this huge traffic jam. So congestion is one thing, but the impact of congestion pales in comparison to the costs and impact of fatalities due to traffic. In fact, there were $230 billion was the economic impact due to collisions. And here's the thing. All of these images that you see here were taken at intersections. Intersections take up a tiny percentage of the roadways, right? There's usually long stretches of road and tiny bits of intersections. But they account for 1/4 of all accidents and 1/3 of all fatal accidents. So this is the X that I'm interested in solving for. Congestion and fatalities, and in particular at intersections. So here's the crazy solution that we have in mind. So you should be imagining here that you're in one of these cars, and rather than stopping at a stop sign or a traffic signal, you can just zip through the intersection, barely having to slow down. Right, so I already heard the comment, I couldn't imagine sitting in one of these cars. You're not in the driver's seat with your hands on the steering wheel. You're in the back seat, you're reading the newspaper and hopefully not looking out the windows. So here's the question, is can it work? Now clearly, with a person at the driver's seat, no, it's not going to work. But as Astro said, Google has been working on autonomous vehicles. So have many people around the car companies now. And there was a community at the DARPA Urban Challenge in 2007. Autonomous cars are here, they're here to stay, they're coming, and they make that solution that I just showed you possible. So let me just take a minute or two to tell you how that video worked. So basically you should imagine that there is, as well as the car being autonomous, rather than the traffic signal, there's a computer program, an autonomous agent, sitting at the intersection, and it's maintaining basically a grid over space-time. So here's the physical grid, and it advances over time. A car, when it advances towards the intersection, sends a message and says, I'm going to arrive at time X, and here's the path I'm going to take. And this intersection manager that we call it simulates the car's path through the intersection, sees which tiles in space-time are needed, and checks whether there's any conflicts with previous reservations that have been granted. If no conflict, then it gives the car the go-ahead, and the car proceeds through the intersection. And if not, it rejects it, it says no, and it's the car's responsibility to slow down and ask for another reservation. Just like if you try to make a reservation for a hotel room, you say, I want to arrive on Tuesday and leave Friday. If they say, no, we're booked one of those days, they don't tell you when to arrive. You then have to either change your travel plans or go somewhere else. So there's a lot of details behind this. We've actually been working on this since 2003, before people even started believing that there would be autonomous cars. And so there's a lot of details under the hood. But the important points of the protocol that goes on here is that there's a set of messages between the car and the intersection that are sent that are formally defined. They're digitally signed so that they can't be spoofed, which is important. And there's a layer of abstraction. The car companies can have their own algorithms for deciding what reservations to request and when to request them. And the intersection doesn't need to know at all about how the car is working. It just needs to tell it, yes, you can go, or no, you can't, just like a traffic signal does. We went through the thinking of what if there's dropped messages due to communication failures. That can never cause an accident. It can just cause a car to be delayed a little bit unnecessarily. And in particular, we can actually implement stop signs and traffic signals using exactly the same set of messages. The key result when we did the initial simulations was that the amount of time spent by cars going through intersections due to traffic signals or stop signs dropped by 2 orders of magnitude when we used this protocol in simulation. So there's a lot of yes ands, I think, but there's also a bunch of yes buts, and I just want to spend the rest of my time preempting a few that you might come up with and that I'm sure several of you are thinking of. And those in particular are, is this safe? What about mixing this with human drivers? And will it work with real cars, not just in that simulation you showed? So let me just take 1 minute on each of these. So first of all, is the protocol safe? Well, of course, if a car breaks down in the intersection, just like now, or if a car goes into the intersection without a reservation, just like a car going through a red light right now, yes, there will be an accident. We can't prohibit that. But if the cars do follow the protocol, then if there is ever an accident due to a mechanical failure, a tire blowing out or something like that, which, by the way, is the rare occurrence for an accident, 90 to 95% of accidents are due to human failures, because they're texting, because they're drinking, they're not, or just made an error. If, on the off chance, an accident does happen at the intersection, then we have a protocol, and I'm not going to go through the details here, but you can stop all the other traffics by basically denying further reservation requests. With regards to sharing with human drivers, we can actually combine this with traffic signals. The humans can still go through a traffic signal. The autonomous cars can go through red lights, but if they don't conflict with the paths that the human drivers could be taking, they'll just be denied reservations that cross where human drivers could be. After a lot of simulations, what we were able to show is that, yes, the benefits basically kick in when there's mostly autonomous cars on the road. We're actually working on this now and trying to make it kick in when there's fewer autonomous cars on the road. But at every point here, the traffic level is on the x-axis, the amount of delay is on the y-axis. As there's more and more autonomous cars, the delay goes down, the throughput goes up, and also people in autonomous cars always get through the intersections more quickly than the human drivers, which also creates an incentive to adopt the technology. Finally, I showed you a simulation, but of course we'd like to see this working with real cars. We've done tests with our own real autonomous car, where we could mix the single car with the simulator. There's a proxy car in the simulator that can sense the simulated cars. The simulated cars can sense it. And we were able to test that this works. And I just am going to close with a quick video. This is just showing that happening with our real autonomous car that participated in the Urban Challenge. If you were just watching this from the outside, it would go up to the intersection and it might stop or it might go through and you wouldn't know why. But if you look on the screen here, it's interacting with a bunch of these simulated vehicles and stopping or going through appropriately so that there's no accidents. And this was one of the ways we were able to validate that this can indeed work on real cars, that even though this is a crazy-looking solution, the technology is there right now to make this happen. And I believe really strongly that this can happen, should happen, and will happen because of autonomous cars in the near future. Thank you.